Hello everyone, my name is Austin Shaner, and welcome back to my channel. Ever since I posted my new Headstock transition method, many of you have reached out to me with problems you're running into trying to use it on your designs. Well, this week I spent some time really troubleshooting this, and I feel like an apology is in order. After I had that breakthrough, I got so excited to share what I had discovered that I actually neglected to include a really critical feature, the neck taper. So the lines that connected my headstock to my neck were horizontal rather than tapered like they should be. This led me to use the extrude command for simplicity's sake on helper surfaces, but that actually isn't the proper method when designing this on an actual guitar with a neck taper. So first off, I sincerely apologize for giving you information that you might not have been able to use. And second, I also discovered some redundant steps in the process and found an easier way to model this without the use of the intersection curve, which will end up making our sketching process much simpler. So today, we're going to fix my mistake, and I'm also going to show you how this method can be used on asymmetrical and angled headstock designs as well. Okay, so jumping into the design workspace, let's take a look at what you need to get started. Now, in the previous video, I had you extrude this surface back to use as a helper surface. Well, if you have your neck already modeled up until that point, extruding that helper surface is kind of unnecessary, as the neck can serve as our helper surface and also provide our taper. Now, it's not necessary to have your heel transition already modeled. All that really matters is that we have the main portion of the neck set up, so that way we can use it as a helper surface. Once you're at this point, we can go ahead and start sketching. So I'm actually going to sketch this with you guys from scratch so you can actually see my sketching process and how I lay these out. So the first thing I'm going to do is I'm going to create a plane at angle on the nut line, and this is where we're going to set our neck break angle. So let's go -10 degrees. That we can always come back and change this because it will be parametric. Hit OK, and then let's sketch on that plane. Now that we're sketching on that plane, let's go ahead and project in the nut line, and let's hide our fretboard. So that way we don't get some of our lines confused. Now what I can do is draw basically a rough rectangle, and I'm going to end up aligning these. And actually, I need to bring back the fretboard sketch. And then we can project in these two lines from the nut. And if you don't have that, you can project in the lines from your fretboard. So let's go ahead and project these two in. Now what's going to happen is you'll notice that because we're at an angle, it's actually projecting those in at an angle, which is perfect because that means we can now make these two lines collinear. So make those collinear and those collinear. And we'll go ahead and make this one vertical. And now we can go ahead and define the overall length of our headstock. So I'm going to make this 7 inches. And now we can go ahead and make these construction lines so they don't impact our design. And go create 3-point arc. And we're going to create it from this point out to here. And I'm going to create another one down here. Now we're going to make these two separate because this is going to be an asymmetrical design. So I'm going to go ahead and say 1 inch on this one. And I'm going to go ahead and say 5 inches on this one. And then now we just need to connect it. So another 3-point arc. And I'm going to go to the point here, make that tangent. And now it just needs to know how high does this point need to come. So I'm going to give that a dimension of 0.75 inches. Come back to 3-point arc from here to here. Make that tangent to construction line. From here to here, and make it tangent to this construction line, but this one's not going to be tangent. Now this is obviously my headstock design, so you don't have to draw it exactly like this. The main thing is that if you're doing an asymmetrical design, make sure that these are dimensioned separately. Otherwise, feel free to use whatever design you need. And then I'm going to make this 0.75 from here, so that makes it fully constrained. And then where do I want this to fall? I'm just going to make it the same as the other one and go 0.75 inches. So that's the design we're going to work with, and we will be able to come back and change these, and it will still remain parametric up until a certain point, and I will show you guys that in a little bit. So now we're going to draw our volute. So I'm going to use the 3-arc method. I still feel like that is the best approach for this rather than a spline. And we will draw an arc here and make sure that it's tangent to this wing right here. And then we will draw another arc that is tangent to this wing right here. And then we will draw a third arc for the volute that connects these two. and we need to make sure they're tangent here, which is already automatically applied, and make these two tangent. Got a little away from me there. So now what we need to do is we need to make this touch the nut line. Now that's where a lot of people got hung up when they tried to do this on an asymmetrical design, because on a symmetrical design you can just make this a midpoint to here, and that makes these two endpoints vertical to each other. Now on an asymmetrical design, that's really not the case, and that's actually not what we care about. What we care about, so the design intent is that we care that this arc is tangent to the nut, and that the peak, the furthest point on the top of the arc, is touching that center line. That's really what we care about. So what we can do is we can click this arc and this point and make them coincident. Let's try that again. Coincident. There we go. And then you'll notice that this arc can breach past that. We need to make sure that it can't breach past it, because otherwise how we cut our surfaces or use an intersection curve or anything like that won't really work. So what we need to do is select these two and make them tangent. Now what that's going to do is it's going to make sure that the peak of that arc is touching the nut line, and then it's also going to be tangent. So now all that's left to do, as you can see, I can still drag it even though it looks fully constrained. All we need to do is give this a dimension and the whole thing will be locked down. So we'll do 0.625. And the last thing we're going to want to do is just give ourselves a construction line across the center, and we're going to use that to help us make some perpendicular constraints on the next sketch. So go ahead and close this out, and now we're going to draw on the side profile. So if I hit sketch and I sketch on this plane, let's rotate this over. What we can do is project in this line right here, that center line that we just did, and draw a point up, the height that you would like your headstock to be, or the thickness rather. So 0.625 inches in my case. And make sure that it's perpendicular. So that automatically applied, but really what you want is you want to select that line, and then come up here and hit perpendicular constraint. Now if you didn't do that and you just hit vertical, you'll notice that that's actually going to throw off our angle on this headstock. So we actually don't want that. So it needs to be perpendicular. And then we can draw another arc, or not an arc, another line over. And then what we want to do is we want to project in the closest wing. So the point of the closest wing right there. And we're going to make these two, we're going to connect these two with a construction line and make that perpendicular. So we're going to go right here, make these two perpendicular, and make sure that's a construction line. And then we're going to make these two perpendicular. But now what we can do is go ahead and draw our arc. So from here to here, make sure that it's tangent. And then what we can do is project in. So if I hide my sketches, I can actually, we'll not use this, we'll use the sketches, not the surface. We'll project in that point, and we'll create an arc from here to here, like that. And actually, we will project in the center line of our neck. So then we can hide that and make these tangent. What that's going to do is that's going to ensure that this arc has a perfectly smooth transition from the neck up. And then what we need to do is create a construction line from here to that peak of the volute. And once again, we need to make that perpendicular, not vertical. So let's go ahead and make here to here perpendicular, and make that a construction line. And now we just need to define the height here. So we'll say 1 inch. That's a little too pointy for me, so let's do 0.875. That looks a little better. And then we can go ahead and draw a vertical line, not a perpendicular line, because now we are drawing on the area that is not at the neck angle. And then we can connect this line to this line and make sure that this is horizontal. And now everything is fully constrained, and I have everything I need, and this sketch is closed off. So let's go ahead and hit finish. Okay, so now we're ready to start modeling. One last thing I want to show you before we actually extrude or loft or patch anything is this is one addition I've made to this process. So before I just extruded this surface, so let me grab that. I just extruded that up until this point. But you'll notice if you zoom in on it really closely, it doesn't actually touch the nut line. And that's because it doesn't take into account the neck taper angle. And that's a problem a lot of you ran into. And so what I ended up doing was creating one more neck profile arc on the nut line and gave myself an additional helper surface or helper arc. So that way I can just simply loft between these two. So we can go create loft, bring back our fretboard sketch, and we can use this as a rail just to make sure everything stays lined up. Hit OK. And we're going to do the same thing on this side. So instead of just doing it on one side, we're going to do it on both sides because we're not going to be mirroring each side of the transition over to the other because it's an asymmetrical design. So let's go create loft from here to here and use this as a rail as well. So now if I zoom in on this, you can see that it's actually coming perfectly coincident to that line rather than missing it like before. So let's go ahead and bring back our neck. And now we can go ahead and start working on the transition. So in the previous video, I used the intersection curve technique. And I still think that is an incredibly powerful way to give you geometry that you otherwise couldn't draw, like 3D sketches or complex curves, splines, etc. But actually, if we understand the concept of the intersection curve, which is essentially extruding this out, right, and then extruding this up, we can actually do the same thing with just extruding and split face. So I'm actually going to show you guys the same idea, but without the intersection curve. So what we're going to do is we're actually going to extrude these three arcs, but not the wings. We're going to extrude those up. And we're going to extrude them up to object, this object right here, or this one right here. We just need it to come to the top of our headstock thickness. Hit OK. And now what we can do, let's bring back those sketches. And now what we can do is extrude these lines over, just like we did before. Oop, disable chaining. These two lines to object. This line here, actually we need to make this two-sided. And this one to that point right there. So just like before where we closed off that section, we did the same thing. But here we're not using the intersection curve, we're just going to use our surfaces and split them with the sketch, which we already did in the previous episode. But we no longer, by doing it this way ahead of time, we actually don't even need the intersection curve. So now what I can do is go ahead and modify split face, and we will select this surface and this surface as the faces to split. And then our splitting tool will be the volute sketch. And if we hide that previous body that we just made, we can use these three lines right here to split the entire thing all in one go. Hit OK. And then now we can go ahead and delete these surfaces because we don't need them anymore, and bring our other one back. So now we have everything but the actual headstock transition modeled. And we were able to do that in less steps than we were before. So there's one more helper surface we need to create, and in the previous video I extruded, let me disable chaining again, that always gets me. I extruded that out. And the problem a lot of you ran into, and I ran into as well when working on an asymmetrical design, is occasionally when you do this, it doesn't actually end up theoretically touching that, and it won't let you select these other surfaces. So what we can do instead actually is hide our sketches for a moment. And what we can do, let's work on the left side first. So let's go ahead and create loft between our neck profile and this half of the arc. And then we can use a rail, which is right here. And then we want to make sure that this, because we selected this surface, we want to make sure that this is set to curvature. So let's go ahead and set that to curvature and hit OK. So that is going to be our helper surface, and that's going to be a big difference because that actually also takes into account the curvature of this arc going around the wing, which the previous one didn't. So this actually ends up with a slightly better result. So now what we need to do is just hide our sketches, and let's go ahead and perform the patch. So let's click these three surfaces, change them to curvature, bring back our sketches. Actually, we can now select this surface. We don't have to use sketches. So this surface, and this surface. And then in the sketches, the only one that needs to close off the boundary is this wing right here. And then go ahead and hit OK, because nothing else needs to be curvature. If I hide the sketches, you can see we now have that half of it. Now, we don't actually need to provide the helper surface on the other one, because we technically already have one. And we have the best kind of helper surface because it's actually part of our model. So I can now just delete that helper surface and do the patch on the other side. So let's go create patch, these three surfaces, change them to curvature, and then select these ones, this one, bring back our sketches, and select that one right there, and hit OK. And that's all there really is to it. So let's go ahead and delete these helper surfaces and patch up any remaining surfaces that we need. So on the bottom side here, you can see that I don't have this flat spot patched, and we don't have this face of the angle patched. So let's bring back our sketches, and we can create a patch on these three surfaces, like that. And then we can create a patch, let's hide our sketches for a second, on this surface, this surface, this surface, and that surface. Hit OK. And now we've already got our headstock. So now we just need to join it to the rest of the neck. So let's hide our body. Oops, wrong body. Let's hide my other components here. Like that. Select the whole thing, and let's stitch it together. Hit OK. And let's reapply our appearance. And see what we got. So now we have an asymmetrical with two different sized wings, headstock, and still have a volute. One thing we're going to want to check is we're going to want to go ahead and check our parametric. So let's go ahead back to where we created that angled plane, and let's try changing the plane before we try to change the volute. And let's change that from like a 10 degree, like maybe I want a 13 degree. Still works. Let's go back and change it to something way more extreme, something nobody will probably ever use, and let's do a 30 degree. That looks kind of crazy, but it still works. So I'm pretty excited about that. That part of it works flawless. Let's go back to 10 degree, and let's go back to our headstock sketch and change the volute size. So let's change this to 0.125. Might need to go a little bit bigger than that. Let's go 0.25. Let's see if I can go a little smaller. No, it won't let me do that because of the way we ended up making this coincident and tangent to the nut line, but that's still, you'll get the point. So hit finish, and that still updates. Another thing we can also check, wrong sketch. We can also check these volute arcs. So let's try changing the radius of this and make it smaller. So let's go like 2 inches. And we still have a perfect transition. Let's go back and let's make it like 6 inches, or let's go to 5. Let's try 6. Now it won't let me do that because at 6 inches, this line will end up being a perfectly straight line and needs to remain an arc. So I guess that is one limitation of this, is there's a theoretical limit to how far that arc can come out before this turns straight. So let's go ahead and finish the sketch. Actually, we need to change that back to a larger volute size. So I'll go 0.625. It's about what I like to use. And let's go ahead and take a look at our zebra analysis and see if we still have some decent surfaces. So click here. If you remember from the previous video, we had a little bit of a jumble here in the middle. Let's see if we can get this looking on straight. It's still not quite perfect because we didn't end up lofting the entire thing, and that's going to be really difficult to do. but it's much, much better than our previous one where it was kind of zigzagged right here. So I don't know about you, but I'm actually quite happy with that. So let's go ahead and turn off our zebra analysis and let's go to the render workspace. Take a look at it with a little bit better lighting. So we've got a nice smooth transition between these two. And it looks like we've got a nice curvature, smooth transition between these two faces here as well. And we still maintained our parametrics, and we were able to do a asymmetrical design. So we didn't have to mirror anything over, and we were able to do it in less steps without the use of intersection curve. Like I said before, I actually still really love the intersection curve technique, but understanding how that worked, we were able to replicate the same results without having to go overly critical with our sketches in order to make that work. We just simply extruded some surfaces up, split those surfaces with our original sketches, and effectively we did the same thing in less steps. So I hope this helps you guys understand how I developed the sketches, and I hope this method helps those of you who are struggling with modeling your designs to get a better result. So before we end this video, I would just like to say thank you to everybody who reached out to me to talk with me about troubleshooting ways of making this design more efficient and more reliable and user-friendly. I would not have been able to come up with it without your help. So thank you again. And for those of you who are not aware, you can reach out to me on Discord or via email if you are running into issues with any of the problems that we've described here in this video or any of my other videos. I'm pretty active on Discord, and you'll probably get a pretty fast reply if you'd like to ask me a question. So thank you guys so much. This is Austin. I'm signing out.